Developing Your AI Strategy with Matthew Renze.
The Azure DevOps podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. ClearMeasure is hiring both architects and .NET engineers who'd like a path to become an architect. You can go to clearmeasure.com/careers, as well as if you need a fractional architect, you can contact ClearMeasure for that. And if you have a comment or question for the show, just send me an email at podcast@palermo.network. And also, you can check out my new online TV show. You can search for, quote, Programming with Palermo in any of the podcast directories. And you can also find it on www.palermo.network. Now, my guest today on the show is a returning guest from episode 44. Matthew Renze is a data scientist, consultant, author, and public speaker. He's the founder of Renze Consulting, an AI consulting company that has trained over 400,000 software developers and IT professionals. His clients range from small tech startups to Fortune 500 companies. He's also the president of Serenze Global, a 501c3 nonprofit organization dedicated to improving access to technology education for underrepresented individuals by empowering the next generation of tech community leaders. Matthew is currently working on his master's degree in artificial intelligence with a data science specialization at Johns Hopkins University. And he currently has double degrees in computer science and philosophy with a minor in economics from Iowa State University. He is a Microsoft MVP in artificial intelligence. He's also an ASPInsider and an author for Pluralsight, Udemy, and Skillshare. His interests include AI, ML, data science, mindfulness, technology education, and tech community leadership. Matthew, welcome back to the show. How are you, sir?
Very good. Thanks for having me.
Oh, my pleasure. My pleasure. It's been a long time since episode 44 that you were on last time talking about data science, but we'll put a link in the show notes for the listeners that might not have listened to that one. And kind of before we dive into AI strategy and how to develop it, for the listeners who maybe are just getting to know you, haven't heard you speak before, you can give some of the high points that have kind of pushed you in the direction of working on artificial intelligence in the first place, and what the heck that means.
Sure. So I got my start as a software developer many, many moons ago, and I kept working on projects that we would call big data projects now, but back then we didn't even have the term big data. Mm-hmm. And I found that my interest on these projects always seemed to involve data analytics and kind of like data visualization, essentially the things that we now call data science. But once again, we didn't have a name for it at the time. So I went back to college, studied data science, and got a degree, actually double degrees in computer science and philosophy with a minor in economics, and then rebranded myself essentially as a data science consultant after spending a few years with a consulting firm. Then I went independent, did my own consulting for, I think I'm on almost year 10 now. And in recent years, I've noticed that there's been more and more of a push towards, rather than data science, with data science, we're essentially helping people make better decisions with data. But with artificial intelligence, we're essentially helping machines make better decisions with data or automating decision-making processes. Mm-hmm. And so with the industry kind of transitioning in that direction, I decided to go back to school again. And so now I'm kind of in the process of rebranding as an AI consultant rather than a data science consultant, still with a foundation of data science. So it's really data-driven AI is probably the best way to describe what I do now. And as far as what artificial intelligence is, now you're going to get different definitions depending upon who you talk to. But most academics will say that it's really one of two things. Either we're creating machines that choose rational actions in response to their environment and optimize some goal of some kind. So essentially, you've got a machine operating in an environment, and it's sensing the environment and then choosing actions which maximize the expected likelihood of achieving that goal. So just think of it as goal-directed behavior. Now, the other kind of computer science-y definition of it is it's essentially algorithms with tricks. And specifically, we call them NP hard algorithms. So they're a more difficult class of algorithm, like the traveling salesman problem. But we apply a bunch of tricks to it, which we typically refer to as heuristics, in order to make a brute force solution, which would take longer than the heat death of the universe, complete in a much more reasonable time. So kind of depending upon who you talk to, those are typically the two definitions. However, in the world of marketing, it's typically anything that a human can't do that a computer has just learned how to do is what we typically call artificial intelligence. Not a great definition because it's always sliding. But even think we were talking about database sorts, earlier. Essentially, a database sort at one point in time was artificial intelligence, but now it's just a database sort. Nobody would, say, "Oh, I've got an AI startup based on sorting a database." So,
gotcha. Now, I want to make sure we don't gloss over some of the concepts and assume listeners know it. Can you give just a quick synopsis of what the heck the traveling salesman is?
Oh, sorry. Yeah, traveling salesman problem is this idea of you've got a bunch of different stops on a map that you have to stop at, and you're trying to figure out what is the optimum route to get to all of these stops most efficiently. And so in order to solve that problem, the complexity of the problem or the amount of time it takes to solve the problem grows exponentially as a function of the number of nodes, the number of towns you have to visit. And so problems in this space, which we call NP hard, are computationally can't be done in what we call polynomial time. So they take a lot longer to solve, and thus as the problems get bigger, the amount of time it takes grows exponentially. So what we're trying to do is find tricks that can reduce these super polynomial time problems or exponential time problems down to something in polynomial time, which is tractable. It's something that we can do in a reasonable amount of time and get an answer rather than it taking millions of years for even a problem with like 100 different towns involved. Maybe that's not the right numbers, but I think you get what I mean. They're the problems that are really hard to do in a reasonable amount of time. We have tricks in order to solve them much, much quicker.
Gotcha.
And we call those tricks heuristics in AI.
So really, in the late 90s, when MapQuest.com came out and was saying, "Oh, it'll give you directions wherever you want to go." Now, it didn't take into account traffic, but that one is probably just brute force. It's like all the possibilities, and it just iterated and then picked the one, right?
Potentially. A lot of times they used a bit of these heuristic tricks, like prefer interstates if you're going long distances rather than looking at every possible road on every possible county highway out there. And so even those tricks can reduce something that, like a brute force solution, literally try every road through every town in, the United States or the world in order to find the optimum route from Des Moines, Iowa to Chicago, Illinois. But, you're simply saying, okay, prefer interstates first before branching off to, street level routes or county highways. Like that alone is enough to reduce that problem to a quite significant reduction in time.
Gotcha. And do you tend to call the mapping services artificial intelligence or just online tools?
It kind of depends on the context. I mean, in reality, at one point in time, doing routing on your computer to get from point A to point B would have legitimately been referred to as artificial intelligence, and anybody would have called it that. Nowadays, a lot of us would just call it, it's just a mapping service because we're so used to doing it. But I mean, at one point in time, this was pretty cutting edge technology. And in similar ways, something like protein folding, which is as cutting edge as we can get in AI, is really difficult to do. And I mean, they've now just recently announced that they have pretty much every protein we know, known to man, essentially has a folding solution now. And that would have been unheard of even a few years ago, the idea that this could be done. And now we've got it solved. And in another 10 years, someone's going to be like, "Oh, yeah, it's just protein folding. Everybody can do that with a desktop computer, maybe."
Gotcha. And can you sort out the difference between AI and ML for us?
Sure. So, and there's a lot of overlap here. It gets kind of gray. So machine learning is specifically using data in order to learn a model so that you can make predictions about future data that you've never seen before. So the perfect example is if you want to build a classifier, a machine learning model to detect cats, you feed it a bunch of images with cats and a bunch of images without cats. And you have a human being label, these are cats and these are not cats. And then that builds a model of all of these cats it's seen, essentially learns what catness is. And then when you feed it a new picture it's never seen before, it essentially through those relationships, it's learned about pixels and cat's ears and whiskers and stuff like that. It's essentially able to predict the confidence it has that this image is either a cat or not a cat. And this is a statistical, confidence. So like we're 99% confident this is a cat, or only 3% convinced. So we'd say, oh, if it's only 3%, then no, that's definitely not a cat. But if it's 99% likely, then yeah, that's a cat. So that's machine learning in a nutshell. And the difference between these is that artificial intelligence typically includes a bunch of other tools in addition to machine learning. And these tools are things like state space search, all of these heuristics I talked about, these little shortcuts we do in the state space search, logical programming. So essentially having computer programs that use I don't want to say like a programming language, but their own logic language in order to solve like planning problems and stuff like that, and constrained optimization. So there's a whole bunch of different tools in like an AI developer's toolkit, but machine learning is one of those tools. And we now have new, more enhanced versions of machine learning like deep learning. And we also have reinforcement learning that are all built on top of this idea of machine learning that all fall under this umbrella of artificial intelligence.
Gotcha. Okay. Well, I certainly have seen, and I'm not AI expert or even journeyman at all, but I've seen just tons of talk about this and that and advertisements. If I put myself in a manager's position who's overseeing a software team, maybe not working in the software team, but some of the people in the software team is like, oh, we should do this and AI and techie buzzword here and techie buzz. What should, speaking of strategy, what falls into that? How do people make heads or tails of what is actually possible and what's worthwhile with AI?
Well, I think the beginning is essentially education. You need to learn, what are the pros and cons of artificial intelligence? What's possible with it and what currently isn't possible, and what things are just over the horizon as well. And that takes a lot of knowledge to begin with. And there's different levels of knowledge or different levels of training that I think need to exist within an organization. At the executive level, you need people that understand kind of the overall, strategy of applying AI to solve problems and understand the economics of it. Getting down to managers, essentially people need to know what problems it's good at solving and what problems it's bad at solving, and then contingencies for when it makes bad decisions. And then at the developer level, you need to have a deep understanding of what these models can and can't do, what the pros and cons are, how to deploy them, how to train them, how to fix issues with bias. The whole slew of technical issues that need to be resolved. And then at the kind of general employee level, I think there's also a basic AI literacy that everyone needs to have, in the same way that I think like data science literacy is now becoming pretty mainstream. You at least need to be able to read charts and data visualizations and understand a bit of statistical analysis for when somebody brings this information to you, so at least you understand what they're talking about. I think the same is going to be true about artificial intelligence and basic literacy there. So having the education in place is really important. And then I think the next big piece of the puzzle is that most of these organizations that have been successful with their AI strategy are essentially doing three things that I've identified. They're automating their operating model with AI. So essentially taking all of the routine tasks, things that are simple, repetitious, dangerous, error-prone, or costly, and they're figuring out ways to automate them with the technologies that are currently available in the AI space. And then the next thing that they're doing is they're essentially placing an AI factory at the center of their organization and then moving people to the periphery of it. In the same way that in an industrial factory, we constrain everything to a conveyor belt and move parts along so that robots can work on those or humans can work on those. We're doing the same thing with data and our services, our software. And then the last thing that you have to do is learn how to leverage the unique advantages that AI provides your organization for competitive advantage. And we can go into each of those, the key topics more in depth. But I think that's kind of the overarching thing I'm seeing that successful AI companies are doing. Automating their operating model, placing an AI factory at the center, and then leveraging that a unique value for competitive advantage.
Okay. Automating operations makes a lot of sense, but people have been doing that for a long time, even before this AI word or acronym existed. So what can be automated now that used to not be able to be automated?
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Well, and even taking a step back, I think, it's that sliding definition of AI that gets everyone kind of confused, because the AI we were doing in the 1970s or all the way back to the 1950s, nowadays we don't think of as artificial intelligence anymore. It's just, we call it software. But the trick with automation is that artificial intelligence is essentially the frontier of automation. AI is allowing us to automate things that couldn't be automated just a few years ago, and it's going to allow us to automate things that would seem fantastical to us today. Like the self-driving cars. I think that's an example that's relatively in the kind of public consciousness. But something like protein folding is something that most people don't know about. But it's going to have fundamental implications for the pharmaceutical companies and drug development. All of these like single protein disorders that happen. There's a whole slew of impacts that this is going to have in the medical field. But it's something we couldn't do, just literally a year ago. It was only this last year, or the current year, that we essentially solved protein folding with machine learning and AI. But like self-driving cars, that's a much more visible example. I mean, you can see how society is going to change pretty fundamentally once the human driver is no longer necessary for an automobile, and then eventually other vehicles, semis, boats, probably airplanes as well. And it'll get to the point where I think humans, the next generation of humans, will probably trust the machines and think, oh, wow, why would we ever allow a human to drive? They're, error prone and dangerous and make risky decisions and stuff like that. I mean, it could literally get to that point if the safety record of the self-driving cars is great. But so going back to your original question, what is the difference now today? And I think the big differences that I'm seeing with this kind of data-driven approach to artificial intelligence is that with traditional organizations, doing traditional, IT infrastructure software and solving problems with the kind of classical tools, we'll just have to call them for now, they're typically just solving these problems with explicit programming. So a human being writes code, if this, then that, do this loop, and then, here's my output. Whereas the companies that are embracing kind of artificial intelligence and more specifically data-driven AI are solving these problems with a wider set of tools, especially things involving machine learning, where it's given this data, what is the most likely outcome for this new data I've never seen before? And that's what's allowing us to automate tasks that we couldn't previously do, because now computers have a bunch of capabilities that the machines didn't have just a few years ago. Computer vision, for example. I mean, machines can see, they can detect objects, they can draw bounding boxes around things, they can do image segmentation. Things in terms of their ability to hear. I mean, we can do speech to text. We can do language translation. Things in terms of like tactile and motor control, which machines couldn't do. I mean, we've seen Boston Dynamics robots doing backflips and stuff. Try doing that with explicit programming. It's just good luck. But, once you get to the point where you've got, reinforcement learning and these other tools in your toolbox, you can now automate a much wider variety of things and with much more precision and accuracy and potentially much quicker. Even looking at the tools that I'm using, like in my IDE, I essentially have Copilot, but I'm trying to think of the full name of it. Is it GitHub Copilot? I think it's GitHub, yeah.
Okay.
Yeah, so Copilot essentially, helps me as a software developer by searching every line of code that's ever been written in GitHub.
Better intelligence.
Yeah, it's like IntelliSense on steroids. But as a software developer, I mean, it does two really important things for me. Number one, it eliminates me having to type simple, repetitious code, because most of the times its predictions are right, and sometimes eerily so. Like I can't even fathom how it came to the solution that it did, except I now understand exactly what the inputs were into its decision. And the second thing it's also doing is helping me become a better software developer by education. Oftentimes I'm working in Python and somebody's come up with a clever way to use a list comprehension to do something that was 10 lines of code, and now it's just a single line of code with some little clever syntactical sugar in it. And I would have never discovered that on my own without like searching, scouring the internet for obscure ways to do something with a list comprehension.
Right.
And so I think it's making me a better developer and kind of augmenting my software development skills through this additional power.
Okay. Now, you had mentioned earlier an AI factory. I've heard of a software factory that now I think a lot of the concepts that used to be associated with that are kind of associated with DevOps and whatnot. But what is an AI factory, and are people arguing over what it is?
So yeah, the AI factory is a term that comes from a book. God, what is the name of the book now? I want to say Competing in the Age of AI, but I'm not even sure that that's the right book anymore. We'll have to put it in the show notes once I remember what the name is. But it's a concept of essentially building a system that helps you to further automate your operating model. So the end goal with all of this is to essentially automate these routine tasks. Well, there's certain things you can build as platforms around your organization that help you to further automate things. And so the main components of it are having a data pipeline. So some system that helps you to collect, clean, and organize the data coming from this automated operating model. So imagine you're Facebook or something. You want to have an ETL system, data extraction, transform, and load, that's collecting all of the data, cleaning it up, organizing it, putting it in some kind of data repository so that it's really quick and easy to get access to it. Because if you talk to any data scientist, they will tell you that roughly 80% of their time is spent finding, cleaning, collecting, organizing, sorting data, getting it ready, getting it in a form suitable for analysis. So if we can eliminate all of that busy work, we can essentially get models built quicker, get data science done quicker, and get things automated quicker. The second piece of the puzzle is a data science pipeline. And so this is essentially a set of tools that allows you to do rapid and low-cost experimentation. Many times it's in a low-code, no-code kind of context. So essentially drag and drop data visualizations. Essentially, you're trying to run experiments as quickly as possible using the data that you have in order to make decisions about what to automate or how to automate it. And then you've got a machine learning platform, which allows you to do rapid and low-cost training of machine learning models. So once you've got that data from the data pipeline in a repository, you need to build a model with it. So having a set of tools that allow you to build these models quick, easy, deploy them, get them changed, and make sure that they're performing as expected is important. And then a DevOps platform seems to be another component I see in a lot of organizations, where it's essentially allowing us to rapidly deploy and change our code and models. Because when you automate the routine tasks in your organization, essentially the organization's behavior is now a combination of code and machine learning models. So if you want to make a change to the business, you don't create a training program and roll it out to a bunch of employees and then monitor them to make sure that they're performing their new duties correctly. You essentially make a code change or make a change to your model, and you deploy it to production and then monitor it to make sure that the code change worked correctly. And then the last piece of this puzzle in the AI factory is essentially people. But people are now moved to the periphery of the factory, the main factory line, rather than being in the center of the line. And the main reason we do this is because when you've automated a process, you've essentially, you introduce points of failure when you have human beings in the middle. Humans still want to oversee these processes and make sure that they're running correctly, but we don't want to have really fast machines, then hand off to a slow human to hand it off to really fast machines again. Think about Netflix as an example. So when Netflix was shipping DVDs, there were humans in the process and slow, it took a while to get your DVD sent to you. Yeah. And now if you've got a completely digital pipeline with no human beings involved, no one has to recommend, no human has to recommend a video to you. No human has to hit the play button. No human has to do, ship the DVD. Essentially, the AI systems recommend the movies. You click on your movie, and then it plays automatically through the internet. And that kind of automated pipeline is what you want. And people are still overseeing everything, but they're not directly involved in the day-to-day operations of watching a video on Netflix.
Okay. So I'm trying to figure out a good analogy to see if I can understand you properly. And I'm thinking of the progression of elevators, where there was a time when there was an elevator operator. There was a person whose job it was to say, okay, this elevator's door, let's close the door, let's move up, let's move down, let's interact with the people. And now it's mostly automated, and interacting with the people is, hey, people, press a button, please. So
yeah, and in some cases, you don't even have to do that. Well, I probably shouldn't go that far. If you have RFID badges and stuff that know what floor you're on, that can even be automated where you don't even have to push the button anymore. But I don't think that's very common. The thing we forget is that elevators at one point in time were like difficult to operate and relatively dangerous. Like the doors opening and closing were not, like safe doors.
Right.
And in some other countries, it's still that way. Like when I travel internationally, I do not stick my foot out in an unknown elevator because I am not guaranteed that elevator is going to stop. It may just continue to close based upon what the safety regulations are in that specific country I'm traveling in. But yeah, I think we're seeing this in a lot of different places, and even computer. Like when you think about the term computer, that was originally a job title. A person's job was to sit with a pencil and paper and compute numbers for other people. And we automated that with this thing we now call a computer. And, I think we're going to see that in a bunch of different professions as well, too. It's this natural transition, but as we have the technology to automate more and more tasks, we will inevitably automate more and more of these tasks, with the exception of some tasks that are going to be relatively difficult to automate. And they're usually because of things like, human creativity, compassion, empathy, trust building, things that machines just are not generally good at, but human beings are, uniquely positioned to do. Yeah. So I don't think we're going to see, teachers, elementary school teachers automated away anytime soon. Nurses are going to be around for a while, even if doctors end up getting automated, and a whole slew of different professions that are robust or at least resistant to automation from AI in the near term.
You had mentioned some of the jobs moved to the periphery, but it seems like, and correct me if I'm wrong, it seems like some jobs are created as well. Like, what's your view on this? The elevator analogy, where there used to be a person in the elevator, and like if someone's foot got injured in the door, it'd probably be that elevator operator's fault because that's their job. Whereas now, every elevator has this, inspection and certified by such and such. And aside from it snapping, if somebody got injured by the door or whatnot, you probably go back to that inspector. I would say it's like, hey, why, if it hadn't been inspected in a while and it was negligent. But do you see that as a theme? As a person gets pulled out of a job, there's another job somewhere else that's created? Because the job still has to be, that function still has to be designed and monitored and maintained, right?
Yeah, I think this is probably the second biggest question in terms of AI and our labor economy. Will we end up with more jobs created as a result of artificial intelligence than are eliminated by it? And right now, it's up in the air. I mean, this could literally go both ways. I'm seeing, I've seen reports on the jobs that are most at risk of automation. And it's pretty clear in what ways this is going to impact our labor economy in terms of eliminating jobs. Things like food service, a lot of hotel and hospitality things are now easily automatable. In fact, in Las Vegas alone, which is a very service and hospitality oriented economy, something like 65% of all jobs in Las Vegas are currently at high risk of automation. And something like 50% of all jobs in the United States are at risk of automation. This is within the next 20 years. And so that's a pretty short period of time to see kind of a radical transition of labor in our economy. And, the jobs that are less resistant, typically things like nursing and stuff like that, I don't see those being anywhere near as at risk. But then the new jobs that are going to be created, these are largely going to be technical jobs. And in some cases, they're going to be jobs that we've never even thought about. Like, I'm trying to think of one that is just kind of out there that will most likely exist, but AI ethics for one. People whose job it is to determine whether algorithms are biased and discriminating will probably be a class of jobs that will be really big in the near future as more and more. I almost want to say like mom and pop stores begin implementing these kind of algorithms, because right now it doesn't make sense for mom and pop stores to build a deep learning model to determine customer churn or something like that. It's not economically feasible because it doesn't scale in mom and pop businesses. But at some point in time, someone's going to build the Salesforce plugin that does this, and then anyone I guess Salesforce mom and pop.
Well, what about dispatcher? Like taxi companies and taxi and town and limo companies have had dispatchers for ages, and we still have actual dispatchers, but if more cars are going to be self-driving and a water main breaks on one of the inner city roads, hey, avoid this road. If somebody has to make the decision, something happened, avoid this road now, and make a judgment call, feed it into the system. And now the automated cars know to avoid that section of road.
Well, if it's a peer-to-peer network, the automobiles detecting that there's a problem with that road would probably just communicate with one another to avoid that road. And then they would balance their exploration and exploitation, as we call it in machine learning speak, in order to try the road experimentally once, I don't know, every couple hours or so, and then back off if it's still not functioning correctly. And a taxi cab dispatcher would be doing the same thing, I assume. As soon as one person reports the problem, the dispatcher would then report it to the rest of the taxi cabs, who would then avoid it until somebody says, oh, no, it's clear now, and then everyone continues to use it. And I don't know why that couldn't be automated. It seems like that'd be... And the other thing to think about is that taxi cab dispatchers are still part of kind of a legacy system. If you think about like Uber and Lyft and all of these other, automated services, there's no dispatcher there. Like we've completely automated that person out of the loop. So, but once again, people are still overseeing Uber and stuff like that. If there's a problem, somebody's going to step in and intervene. But if the system's running smoothly, typically you don't have to have a human in that part of the loop.
Yeah. Well, this is certainly a fascinating area. And just before we close, I have kind of one final small question. Since you work in this day in and day out, is it data or data? And is that term singular or plural?
That is a great question. So I am guilty of this. And in fact, I'm not kidding about this. My single biggest complaint in terms of feedback from my audience at Pluralsight is that I arbitrarily switch between data and data from time to time in my courses. I have intentionally, and I'm not kidding, I have spent a lot of time working on this to always say data because more people seem to prefer data than they do data. And this is going to probably cause a flame war or something on your discussion forums. But I've worked diligently to try correcting this so that I only say it one way going forward. But I still notice that there are certain contexts where I seem to lean the other way. So like when I say big data, I almost always say data. Yeah. But if I say data science, I never say data science. I always say data science, which is kind of weird. And as far as the singular and plural, so technically it is data is plural because datum is singular. But in common speak, most people just say data to mean singular as well. So,
like
but
this
I
set
typically
of data.
I typically say, yeah, these data tell us such and such. But everyone thinks that it's stuffy and academic when I do it that way.
All right. So for the young professionals out there listening who are just confused by this, the industry doesn't have it figured out. Don't worry about it.
That is correct. We're still working on it. We've got a long ways to go.
Awesome. Hey, well, thanks, Matthew, for coming on the Azure DevOps podcast and sharing with us about developing your AI strategy and how to think about it. We appreciate it.
Absolutely. Thanks for having me.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.